So, what we're going to look at now is energy transfers. There are a number of energy transfers you need to be familiar with and understand, and give examples of each. You need to know that kinetic energy is a kind of movement energy. GPE, or gravitational potential energy, is the energy that something has depending on its height above a reference point. That when you stretch a spring or something like that, you give it spring or strain energy. Chemical energy is the energy that you find in chemical batteries. It's the energy you find in food and so on. Electrical energy is the energy that you have traveling through electrical wires, which will turn on a light and so on. Solar radiation energy is the energy from a light bulb in radiation energy, or from the solar energy, it's from the sun. Sound energy is when you produce sound. And thermal or heat energy is when heat gets transferred from one body to another. Also, nuclear energy is a form of energy that we need to be aware of. Now, you need to be able to look at devices and understand what are the energy transfers, and it normally takes the form of this energy A turns into energy B. In the first one, we have what's called a stylophone. You press the metal pen on the stylophone and it makes a sound. So basically the energy comes from the battery, which is chemical energy, and then gets turned into electrical energy. Then that electrical energy gets turned into sound energy. So there are two energy conversions there. The solar cell is basically solar energy or radiation energy. Solar energy gets converted directly into electrical energy. An electric circuit, the energy comes from obviously the battery, which is chemical energy, gets turned into electrical energy. Then the electrical energy gets turned into light or radiant or radiation energy, also some heat energy. A match, the reason a match lights is because it has chemicals in it. You rub the chemicals against the surface and you produce heat and light energy. A music box, you turn the music box. What happens there? Well, the kinetic energy that you put in gets turned into sound energy. Then also the figure jumps out of the box, so there's a spring inside there, so that spring or strain energy gets turned into kinetic energy. Here we have Darth Vader, and he says, "I am your father." So you wind up Darth Vader and you let him go. What happens? What does he do? Well, he basically walks around. So inside you have spring energy. That gets turned into kinetic energy, and also sound energy will make some noise. He doesn't actually say, "I am your father," it's just a toy. A mass and a spring, okay, you let the spring oscillate, and this is interesting because the spring energy, as you stretch it, gets turned into movement energy, and then goes up to the top into gravitational energy, then back into movement energy, then back into spring energy. So there's lots of transfers here. A pendulum is a similar kind of thing. If you move it high, it basically has gravitational potential energy that turns into movement energy. Then this movement energy, or kinetic energy, turns into gravitational potential energy, and so on. Now, there's a particular form of energy, or two forms of energy, that you need to be aware of, and there are mathematical equations that go with these. That's GPE, gravitational potential energy, which is mgh. M is the mass, G is the gravitational field strength, which is 10, and h is the height above a reference point, 0 point. Then there's also kinetic energy, which is half mv squared. M is the mass and v is the velocity. And we need to do an example of this now. We have a roller coaster here. There's a chap on the top of the roller coaster in a truck, and it moves down, and what happens is that potential energy at the top gets converted into kinetic energy. So as it loses its potential energy, it gets converted into kinetic energy, and basically all energy gets converted into other forms of energy. No energy is lost or destroyed. It always changes from one form to another, and we're going to look at that mathematically now. So this is equations we need. For example, you've got a 100-kilogram truck, that's the person and the truck together, at the top of an 8-meter track. So it's 8 meters high. You've got to find the gravitational potential energy. So this is mgh. M is equal to 100, G is 10, H is 8. So it's 100 times by 10 times by 8. We'll give you a value of 8,000 joules. So let's draw this here. We have 8,000 joules at the top. Now when it's halfway down, it's only got 4,000 joules, which means that 4,000 joules has been converted into something else, actually into kinetic energy. So there are 4,000 joules of kinetic energy now, halfway down. When it gets to the bottom, there's no potential energy. It's at the 0 point, the 0 reference point. So this is now 0 joules, but it means that where has all that energy gone? All that kinetic energy has gone to kinetic energy, so that will have 8,000 joules now. Then it starts to move up a little bit, and we can say that it's halfway between the 0 and the 4,000 joules, so it's going to be 2,000 joules of energy, which means that there must still be 6,000 joules of kinetic energy. So we have to find out what is the velocity at the bottom of the track, given that it has 8,000 joules of kinetic energy. There's the 8,000 joules that it had at the top. Now it's kinetic energy. So the equation is kinetic energy is half mv squared. We have to substitute the values. We know that the kinetic energy now is 8,000 joules, and that's going to be half times by m. M is 100, v squared, we don't know what that is. So we know that this v squared, let's rearrange, is equal to 8,000 times by 2, because we're here, we divide by half, and then divide by 100. So we end up with v squared is equal to the same, 16,000 divided by 100, which is basically 2 times 80, which is 160. This is equal to v squared. But this is not the answer. This is v squared. We want to find out what v is, the velocity. So we basically have to square root 160, which is a little bit more than 12. So this is the velocity at the bottom of the track here. And this is what you need to be able to do. Basically convert one energy form into another.